as you know that already we have learned about quadratic equations, how to frame the quadratic equations. In fact, before that we learned what is the standard formula for quadratic equations, and we all know about that is ax square plus bx plus c is equals to 0. It is called as a general or the standard form of a quadratic equation with a variable x. And later onwards, what we did how to solve the quadratic equations. And you are aware about there are three methods to solve the quadratic equations. That is nothing but getting the solutions for the value of x. And those are, first one, it is a prime factorization method, and we also call it as a splitting a middle term. Next one is completing the square method, and last one is formula method. So we already learned all those methods, and by using those methods we have did some sums in our previous classes, and now what we do today is that we learn one of the special characteristic of a quadratic equations, and that is called as a nature of the roots of quadratic equations. Usually what happens, what do you mean by a nature? Nature is nothing but it is a characteristic. Characteristic means is the quadratic equations have roots have some characteristics. Of course, they have some characteristics, and that's something we are discussing in today's class. And first of all, so we are aware about the quadratic formula because we have learned already in the previous class. That is x is equal to minus b plus or minus root b square minus 4ac divided by 2a. It is the formula to find the roots of the quadratic equations. And in this formula, especially this factor b square minus 4ac, it is having certain special character. And by the special character of that factor b square minus 4ac, we can find the nature or the characteristics of the quadratic equations, roots of the quadratic equations. So then what is that character? So what are the natures? Let's see here. So we call b square minus 4ac as a discriminant. So it is also called as determinant. The another name of discriminant is a determinant. And usually if you go by the literal meaning of the word determinant, it says that determining something. So what do you mean determining here? You are determining the nature or the characteristics of the roots of quadratic equations. And without solving sum, how you can find the nature of the roots? So if you know or if you are aware about the value of b square minus 4ac, then you can easily say that what kind of the nature the roots has. So that's why it is called as a discriminant, or it is also called as a determinant. So which one we call it as a discriminant? It is the factor called b square minus 4ac in this formula. And suppose the value of d is 0. If the value of d, that is b square minus 4ac, is 0, then the roots, the nature of the roots is the roots which we get, they are real and equal roots. They are real and equal roots. So if the value of the d is greater than 0, that is positive, then what kind of nature of the roots we get? The roots are real and they are distinct. They are real and distinct. And the last one is, if the value of d, that is b square minus 4ac, is a negative, then what kind of roots we get? No real roots. Now, you may ask, what is real and equal? What is real and distinct? What is no real roots? To get complete information about this, we'll see some videos which I will play now. So you will come to know the exact meaning of the real, equal, real, distinct and no real roots by seeing this video. Observe it carefully.
must have learned how to solve the quadratic equation using the quadratic formula. Did you know that you can also determine the nature of the roots of a quadratic equation with the help of this formula? In the quadratic formula, if b square minus 4ac is greater than 0, we will get two distinct roots of the quadratic equation as shown here. Let's see what happens when b square minus 4ac is equal to 0. When b square minus 4ac is 0, we have x is equal to minus b upon 2a. So, both the roots of the quadratic equation are equal and real and equal to minus b upon 2a. Now let's consider the case where b square minus 4ac is less than 0. In this case, the part of the quadratic formula under the square root is negative. There is no real number whose square is a negative number. So we do not get any real root of the quadratic equation. We see that in each case, the nature of the roots of the quadratic equation is determined by the part b square minus 4ac. Therefore, b square minus 4ac is called the discriminant of the quadratic equation. Let us summarize what we have just learnt. If the discriminant b square minus 4ac is greater than 0, the quadratic equation has two distinct real roots. If the discriminant is equal to 0, the quadratic equation has two equal real roots. If the discriminant is less than 0, the quadratic equation has no real roots.
Students, here I want to add one more point regarding this no real roots. So I'll give a few examples now. We all know that minus 2 into minus 2 is nothing but plus 4. At the same time, plus 2 into plus 2 is also 4. And we have learned from our 8th or even from 7th standard itself that what is a square number? Square number is obtained by the product of two same numbers. So minus 2 and minus 2, it is when it is multiplied by 2 times, we will get the answer as a 4, and 4 is called as a square number. Similarly, we get the same answer 4 if you multiply even plus 2 into plus 2 also. So we say that 4 is a square number. Then what about its square root? Square root of 4. Square root of 4 means from which number, from the number which you multiply by twice, which you got the number that is a square number, then its opposite it is. The square root of 4 is nothing but what is the basic root in that. So square root of 4 is, you can write it may be plus 2 or it may be minus 2, because plus 2 into plus 2 is also 4, even minus 2 into minus 2 is also 4. So square root of 4 is either plus 2 or it is minus 2. But think of a number in which you will get inside the square root as a minus 4. Do you get any answer for this root of minus 4? It is absolutely impossible, because it is impossible for us to get a minus 4 by multiplying minus 2 into minus 2, also it is plus 4, and plus 2 into plus 2 is also it is a plus 4. Hence, square root of negative is not existing. Square root of negative number is not existing. That's why we say that if b value, that is b square minus 4ac, that is inside the square root, if it comes negative, then we will not get the answer. That's why we say that there are no real roots. But when it comes positive, yes, because we are getting always positive answers. If it is 0, no problems. When it comes 0 is 0. So with negative, we cannot get real roots. Then what kind of roots we'll get? We'll get imaginary roots, and that you will learn in your higher classes when you go to PUC classes. Then you will learn about complex numbers. So let us go with some examples to clarify the nature of the roots by taking few examples. let's see some examples from this, and then.
So, now you know how to determine the nature of roots of a quadratic equation.
So students, here is an example. So we'll take this example and we'll see what is the nature of the roots of this quadratic equation. So here it is, the equation is 2x square minus 3 root 5x plus 5 is equal to 0. So usually what we do, whenever we ask to solve the quadratic equations, either we can follow splitting the middle term or the formula method. But here the question is regarding finding the nature of the roots of the quadratic equation. So when you are finding the roots of the quadratic equations, first let us come to know what are the real coefficients in this. A is nothing but 2 here, and B is nothing but it is minus 3 root 5, and C is nothing but it is 5. So A is 2, B is minus 3 root 5, and C is 5. So we are not finding the roots, we are finding the nature of the roots, and to find the nature of the roots we need to find discriminant, and we know that discriminant is b square minus 4ac. So here b square means what it is? It's a minus 3 root 5 whole square minus 4 into a into c. 4, what is the value of a? A value is 2 and c value is 5. So we substituted the values of a, b and c. And next, minus 3 square is a 9 and root 5 square is 5 minus 4 into 2, 8, 8 5 is a 40. So here 9 5 is a 45 minus 40. So what is the value of 45 minus 40? It is 5. It is nothing but we got d is greater than 0. D is greater than 0. D is greater than 0 is nothing but d is positive. And just now we learned when the value of d is 0, the roots are real and equal. When the value of d is positive, then the roots are real and distinct. So what is the nature of the roots here? Roots are real and distinct. The roots are real and distinct. We came to know the nature of the roots of this quadratic equation, and though they are real and distinct. But how can we confirm it? Let's solve using the quadratic formula method. And quadratic formula method is x is equal to minus b plus or minus root b square minus 4ac whole divided by 2a minus, in case of b it is minus of minus 3 root 5 plus or minus, and b square minus 4ac is root 5 whole divided by 2 into 8, that is 2 into 2. So it is a minus into minus plus 3 root 5 plus or minus root 5 divided by 4. So now if we solve this one, next what we get is that the value of x, the roots of x are, one is 3 root 5 plus root 5 divided by 4, and another root is 3 root 5. Here is there another one, that is minus root 5 divided by 4. So how many roots we got? We got 2 roots. And what is the nature? They are real roots but distinct. Distinct means 2 different roots. 3 root 5 plus root 5 by 4, and another is 3 root 5 minus root 5 by 4. So these are 2 different roots. So next what we do is that we'll see some verbal sums or day-to-day life sums from this. We'll take few examples and we'll try to solve those equations.
You must have learned how to solve the quadratic equation using the quadratic formula. Did you know that you can also determine the nature of the roots of a quadratic equation with the help of this formula? In the quadratic formula, if b squared minus 4ac is greater than 0, we
हाँ सर.
We have seen how quadratic equations are solved. Sometimes, day-to-day situations may arise where quadratic equations may be used to determine the solution. Let's look at an example. Anita is Neha's sister. Neha is younger than Anita by 7 years. The product of their ages is 144. Find their ages. Our first step here should be to identify the unknown quantities and check for any relationship between them. We can then convert the word problem into a quadratic equation and solve for the unknown variables. In this case, both Anita's and Neha's ages are not known, but we are given that Neha is younger than Anita by 7 years. So, if we assume Anita's age to be x years, we can say that Neha's age is x minus 7 years. There is yet one more relation between their ages. We are given that the product of their ages is 144. We can thus say that the product of x and x minus 7 is 144. Now, we have a quadratic equation in x. Our next step is to solve the quadratic equation formed. Splitting the middle term of this equation and simplifying it, we get the values of x as 16 or minus 9. Finally, choosing the appropriate solution which satisfies the given conditions, we interpret the solution in terms of the problem, that is, in verbal language. We have two possible solutions for x here. But since minus 9 cannot be the age of a person, this value does not satisfy the given condition. So, the correct value of x for our problem is 16. We had initially assumed Anita's age to be x years. We can thus say that Anita is 16 years old. Also, Neha is 7 years younger than Anita. So Neha is 9 years old. Now, you have seen how we made use of our knowledge of quadratic equations to solve a daily life problem. By following these 3 simple steps, let's try another example. In a 2-digit number, the digit at the units place is 1 more than the square of the digit at the tens place. If 27 is added to this number, then the digits get interchanged. Find the original 2-digit number. Here, we are given a relation between the digits at the tens place and the units place of a number. Let's assume that the digit at the tens place is x, as the digit at the units place is 1 more than the square of the digit at the tens place. We can say that the digit at the units place is x squared plus 1. We can thus write our number as 10 times the digit at the tens place plus the digit at the units place. So our number is 10x plus x squared plus 1. If the digits are interchanged, the new number will be given by 10 times x squared plus 1 plus x, that is 10x squared plus 10 plus x. Now, we are also given that when 27 is added to the original number, we get the new number with interchanged digits. So, we can say that the original number plus 27 is equal to the new number. This equation can be simplified to obtain a quadratic equation in x. Now, to solve this quadratic equation, we split its middle term and simplify it as shown. We get the values of x as minus 1 or 2. Since the digit of a number cannot be negative, we do not consider the value -1. Hence, the correct value of x for our problem is 2. Since our original number is given by 10x plus x squared plus 1, we can substitute the value of x as 2 in this equation. We thus get our original number as 25. Simple, isn't it? Now, take a look at this example. A stationer buys notebooks in bulk from a retailer. When the price of a single notebook goes up by 4 rupees, the stationer gets 10 books less than what he used to get for 800 rupees. Find the original cost of one notebook. In this case, we are given
Students, now let me give a chance for you people now to solve this sum. So you have aware about how to frame a verbal sentence into quadratic equation form, then how to follow the steps you have seen through the video. So let me give you a chance to solve this sum by yourself. Yes, students, I think you have got some time to solve this sum now. I hope you might have done it. Let's see that whether you have done it right or not. We'll check through this video. If any queries, you can correct with the help
that the
of
price of a notebook increases by 4 rupees. Let's take the original price of a notebook as x rupees. Then the new price of a notebook will be x plus 4 rupees. The number of notebooks that can be purchased for 800 rupees at the old price will be given by 800 divided by x. Similarly, the number of notebooks that can be purchased for 800 rupees at the new price will be given by 800 divided by x plus 4. We are given that the stationer gets 10 books less for 800 rupees at the new price. So, we can say that the difference between the number of books that can be purchased for 800 rupees at the old and new rates is 10. This equation can be simplified to get a quadratic equation in x. To solve this quadratic equation, we split its middle term and simplify it as shown. We hence get the values of x as -20 or 16. Since the price of an object cannot be negative, we do not consider the value -20. Hence, the correct value of x for our problem is 16. So, the original price of a notebook is 16 rupees.
Okay.
Okay, students, here this problem is having some complications. Let me stress on those points. Here, especially this part, you can easily understand, but here, framing of the equations. So observe it carefully. A stationer buys notebooks in a bulk from the retailer, and when the price of a single notebook goes up by rupees 4, the stationer gets 10 books lesser than what he used to get it. So find the original cost of one notebook. So therefore, our main aim is to find the original cost of the notebook, and we have taken it as a x. Next, the new price of the notebook, it is taken as a x plus 4 because the condition is there. When the price of a single notebook goes up by rupees 4, means it is increased by rupees 4, that is x plus 4. So it is the cost of the new price of the notebook. Then, number of the notebooks that can be purchased for rupees 800 at the cost of rupees x is taken as 800 by x. Why it is 800 by x? 800 is the total amount and x is the number of notebooks, price of the notebook of one book. So it is taken as 800 divided by x. So 800 is the total amount and x is the price of one notebook. And if you divide total amount with the price of one book, you will get how many number of notebooks you have purchased. So how many number of notebooks you have purchased? It is total cost divided by cost of each notebook. But the question is, the price of each notebook is increased by ₹4. Then how many number of books you can purchase? The total cost remains the same, but the number of books is reduced. So that is why we have taken it as 800 divided by x plus 4. And now why you have taken 800 by x minus 800 by x plus 4 is equal to 10. Here, because 800 by x is the number of notebooks purchased when the cost of the book is x rupees, and 800 divided by x plus 4 is the number of books purchased when the cost of the book is x plus 4. And as you know that when the denominator increases, the numerator number of books purchased decreases. So here in this second case he purchases less books than in the first case. And how many less books he purchases? It is given that he gets 10 books lesser than what he purchased before. So that's why we take how many he purchased before minus how many he purchased later, and that difference is 10 rupees. And next is, as usual, by taking LCM, we get a quadratic equations and we'll solve these equations. Either you can solve it by splitting the numerator like it is shown here, or you can use even formula method. Fine. Okay students, now we have got some question bank here in the data class edge. So many questions we can get here, and I select one verbal problem from this question bank from the data class edge. Here is one question. Rahul participated in a quiz competition. It consists of 2 rounds, and the sum of the scores obtained in both the rounds is 60. The product of the scores is 900. Is this possible? If yes, determine the scores of each round. So here is one verbal problem. See, actually you need to stress on this word, that is this possible. Is this possible is nothing but it is a question which is based on the nature of the roots of the quadratic equations. When the real roots are possible, when the d value is 0 and the d value is positive. If the d value comes negative, then in that situation is not possible. So here, first we will convert this equation into this verbal problem into an equation. Then later onwards, we'll check it whether this situation is possible or not. And if it is possible, then we'll find those roots also. So let's see first, Rahul participated in a quiz competition. It consisting 2 rounds, and the sum of the scores obtained in both the rounds is 60. In both the rounds, it is 60 only, and the product of the scores is 900. So what we do is that let the score means the scores of the Rahul in the first round. The first round score is taken as x. The first round score is taken as x. Similarly, the score of the Rahul in the second round, let it be taken as second round, let it be taken as 1. So now the question says that sum of the scores in both the rounds, how much it is? 60. So sum of the scores. What is his score in the first round? X. What is his score in the second round? Y. Sum means what? X plus 1. And what is the sum of the score? It is 60. So we use the first condition, BTC. It means by the condition. What is the condition? Sum of the scores is 60. So we use it. Now next one. Product of the scores is 900. Product of the score is 900. That is nothing but x into y. First round score x, second round score y, and the product is 900. So now this is an equation involving two variables. But now we make it into a single variable with a quadratic form. So what we do is that we keep y here, send this x to that side, so then this is 60 minus x. We take it as equation 1 and we include this value in this equation. So x is as it is, but what is y? Y is 60 minus x is equal to 900. So 60 into x is the 60x. And x into minus x is a minus x square is equal to 900. So now what we do, we transpose these two terms to RHS. So what we get by transposing, we get minus x square comes to RHS, it is a plus x square and minus 60x. This 900 remains there only, that is plus 900 is equal to 0. So now the question is this situation possible? Let us check it, whether it is possible or not. So for that we need to find the discriminant, that is b square minus 4ac. Then b is minus 60, so b square minus 4 into a is 1 and c is 900. So it is 3600 minus 9 into 4. 36 and this double 0. So both cancels and the answer is 0. So we got d is equal to 0. And we know that when d value is 0, real roots are existing and both roots are equal. So then this is possible. So you can find it. So you can determine the scores by yourself. Okay students, as you know that we have got the value of b is 0 and you can get the scores of round in first round and in second round. I hope you will do it and we'll see the few more application based sums in the next class by using this data edge problems. Okay, thank you children.